Alright, hey, what do you know? It's Doozer shop here. Another weekday, and I'm in the shop this evening, and I've been tying up some loose ends, trying to. You guys maybe know, a while ago, probably a year ago, on the, the Colchester lathe, I did a lot of work on the apron and the power feeds and a whole bunch of mechanism, mill and oil grooves and whatever. So the lathe is like 99% done, and the last kind of thing I had to do was give some love and attention to the tailstock. Now the tailstock, I didn't put it back on the bed, it was sitting on the ground forever. And I was like, man, I gotta do a few things. I bought a Morris Taper 4 reamer to ream it out. Some stuff had spun, but anyhow, let me kind of take you handheld and show you my process and where I'm at and what I found and da-da-da-da. So let's go handheld and here we go. All right, let's go to the dude in question. 17-inch Colchester. I think this is 1976 vintage. A little bit later one before the square heads. It's a round head. I think it's called the Mascot. This is the Clausing Colchester, so it's got the hardened bed for export to United States. I got the hand wheel off of it, and it looks just like the same as that hand wheel. I got the oilers out because they were just trash, and I put little just vacuum caps in there. So this unscrews. There's a set screw in the back, but this unscrews. I didn't have a pin spanner to loosen it. I had a hook spanner, so what I did is I put a 1/4-inch dowel pin in there and just used the hook spanner. And I had to heat the butt end of it with the torch before I really tried putting a lot of force on it. I didn't heat it too much because it's chrome. I got the butt end of it blue, but the chrome is fine. So that's off. So I got the ram out. Yeah, you see it's maybe you can't see. It's got a key in there, not a set screw or whatever, and it's got some cotters. It's got the cotters. There's one cotter for locking it, and of course the other cotter is on this little lever. So that's how that works. To adjust it, that bottom nut loosens the split line, and these set screws adjust it side to side. The actual hold down nut for tightening it is left hand thread. Why did Colchester do this? I don't know. It's kind of opposite, kind of messes with my brain. I put a ball thrust bearing in there just to make it tighten a little nicer, a little better. So anyways, coming back up, my process was this. This sucker was on the floor and dirty and da-da-da-da. And before I set it down, I cleaned it. You can see it sets on the ways there. What I have, let me pan you up. Doodle-doo. All right, above the lathe, I have an I-beam. It's a 4-inch I-beam. You can see I got a couple chain hoists, and it services most of the shop. The boring mill, the SIP jig bore. Anyhow, so I got this old hoist. I love these old hand chain falls, they call them. And what I did, well, you can see the bottom. You know what it looks like. Hooked it up. Oh, there it is. There's the hook. Hooked it up, and in this little area I've got between the vices and the SIP. My parts washer, let me back up, is on wheels, right? I got a drum on that red caster dolly. So what I did is I hoisted up the tailstock with the chain fall hoist on the beam, and I dangled it over the the parts washer sink, which is kind of where I'm standing. So, it's got the pressure the pump down there, and it's mineral spirits. It's a bit dirty, but it's fine. And this is a big long scoocherooski, and it can reach up to the top. So I cleaned it super well. All the grit, man. I really got to stress to people: you get a machine, you got to clean everything like it's almost surgical clean. That grit gets on the bedways, on any slideways, it's going to just wreak havoc. So again, I put this beam in, it's tied into the roof structure. I would only lift 500 pounds with it. It's, you know, for chucks, right? I mean, it's great for chucks and you know, if you got a heavy vise or a rotary table, whatever, it's good for that. I put this on there. This is a coal vise. I had this upstairs. I needed a narrower vise for something I was doing, and I got the big Vanderman #3 or whatever. So I put the coal vise on the vise stand. Seems to work out. Da da da. Okay, that was a side note. So anyhow, I got my #4 Morse taper reamer, and then I found a 12-sided socket to fit it. And I reamed out the tailstock, I guess you'd call it the quill, and came out pretty good in this Morse Taper 4 drill shank. Seats in there very solidly. But I noticed something was going on. When I ejected it by running the wheel all the way back, pop out the taper, everything got kind of tight on the lead screw. And it wasn't tight in the barrel, it was tight in the screw. Let me roll you over. All right, let's see here. It's a big red hand wheel. So this is the feed screw from the tailstock, and it's 3/4 5 Acme, 3/4 inch 5 threads per inch Acme, 29-degree Acme. So you're like, whoa, what's going on with that? Well, it's not as bad as you think. What happened is, this is the nut, of course, out of bronze, and it goes in the back of the quill for the tailstock. And how it's retained, it's pushed into a bore. A lot of these have Dutchmans in them, and Dutchman is like this case would be the 1/4 tapped hole right on the interface, right on the line between the bronze nut and the steel tailstock quill. Kind of makes it a custom assembly, because if you ever take this out and had to replace the Dutchman, you're trying to match up a half a threaded hole. It's not going to be that easy, if impossible. So you abandon it and you put a Dutchman next to it, and that's just, I don't know, it's kind of hokey for replacement parts point of view, but I know it's probably never. So what you see there, that's a cross pin hole, right? And the thing is, the cross pin went right through the tailstock, and it's offset from center, of course, because if it was dead center, it'd just go through everything. So this cross pin was used to retain the nut that was in the bore, or the recess, or whatever. And, you know, it would seat against this face, driving the drill or the center or whatever, but retracting the tool, it would be pulling outwards on that pin, that cross pin. So what it did is it blew all this out, all the force. Just whole probably started as a small crack, and it lasted probably, 40 years before this happened. But anyhow, it's not really that worn. Not that much backlash. But anyways, so I'm going to take you over to the mill. So just remember this situation. It gets cross pinned and in the ram, and I've been investigating different things. Do I want to make a new one? I got a boring bar. It's not quite the same as an Acme thread. It's almost like half an Acme thread. Oops. Yeah, there you go. That's the meat side, the cutting side. I could grind it down and change the angle. It'd make it a little less stick out, but I calculated I'd have enough. So I got the, I don't think the AccuFinish Glendo is going to help me at all. So I really don't have to make a nut. I've been looking at options to make a nut. This piece of tool steel for making a boring bar. This is a 1/2 inch, and I ground half of it away. I got to grind some of it down. I'd flat the top of it, of course, but that's clearance inside the bore. You know, if that was a new one, that'd be like going in there like that and cutting it, and that's what this clearance is for. It's longer than I need. But this thing is tough. This was a Keo brand. You can see it. Center drill, double-ended, extra long center drill. That was a Keo, whatever. But high-speed steel. I ground this there the other day just to get as far as I did. Boy, that took a while. Well over an hour. So anyhow, might make a new one. Might use a carbide tip one. I could order a tap from McMaster Car for like $160. I could purchase a solid carbide bar for like $70. Insert bars are ridiculous. I could reuse this because it's not, it does function. Anyhow, I'm trying to repair this. I'm trying to make this also so it doesn't break again, right? So if I make a new one, and I can even buy a new one from McMaster Car, but anyways, buy a nut, that is. I don't want it to break again. So this cross pin dealio, yeah, didn't work. Maybe I should put 2 cross pins, one on each side, double up the potential of strength. I kind of like that to some degree. But I want to make a flange that bears on this face that keeps it in the back of the ram, in the butt end of the ram. So remember what that is, and remember this whole thing. Let's go walk over to the mill. Not trip over nothing. I'm on walkabout here in the shop. You guys like walkabout. Alright. So, I know it looks crazy. That's, back up even more. So, the Clausing 8520 with the Bridgeport head, right? So, this is a very small mill, but it's like the only one I got with a digital readout. So, let me show you what I got. That big hole, it's an 1.25 inch hole, counter bore, whatever you want to call it. That bore is where the nut goes, the bronze nut, the bronze Acme nut. And the cross pin, it gets pinned across, yodel hee-hoo over there. So this dude is a cross pin. Getting that out was a huge pain in the butt. It was. I know it's hard to see on camera, but this pin is not crossed directly in line parallel with this. It's off kilter a little bit. If it was dead center and I was aiming the camera at the key slot, keyway, then, but whatever, here and there. But that was the existing pin that held it in. Like I said, if I put one, I'd put another one over on this side. So that would probably be good. That'd be decent, 2 of them. But what I did, I got the Taparaski and the Drillaruski, and I drilled and tapped 6 holes, 10 32 holes. And you can see I straddled the keyway. So what that's going to do is put a flange. I'm going to make up probably a 1/4 inch thick, at least, steel flange to retain the bronze nut. Now, that should work. I'm kind of excited that, you know, I got kind of a good stout solution. 6 of these. I thought about doing 4. I thought the plate might bend for not being strong enough. So I did 6. How did I do 6? Well, I'm lazy, and you know I do know trigonometry, but I printed this up in SolidWorks, and I got my dimensions for up 704, my dimensions for over 406, and just did the different quadrants, and kind of just what fit and how did it fit, and that seemed to be the good solution for me. This is a 3/8 Studley, and the stud has a nut and a thick flange washer. I got to use 3/8 because that's what this table is, right? So I had different length whatevers. Got a coupling nut because it's so dang long, but it's in the slot, holding it down. Now, the other face was kind of beat up around the Morse taper. I faced it and made it nice and true before I put it up against the table. This is just sitting on the table, folks, right? Held down by one threaded hold down. Now the chuck, you see, Doozer, you got this big, this is a 10-inch Bison 3-jaw, 10-inch Bison. It's just sitting there. This sucker is so heavy, 40 pounds maybe, I don't know. But I just got it sitting there to make sure everything is square, straight up and down, right? So it's just sitting, the chuck is not fastened to the mill table. It's just kind of sitting there just to help facilitate alignment in the vertical plane. So that's kind of it. Like I said, I wanted to make another nut. I got, this is aluminum bronze. So that's a possibility. Tensile strength is over 50,000 psi on this stuff. It's better than mild steel. It's crazy. Anytime someone thinks about the Bronze Age as being, you know, kind of wimpy, man, they make some good bronzes. At least nowadays they do. Aluminum bronze. Anyhow, so that's that. Yes, I was too lazy to take the vise off the mill. Absolutely, I can tram a vise very easily. I'm working with minimal daylight here, but it was enough. This thing is like, what was it, 13 and change inches tall, but this little Clausing 8520, man, just kind of back up. It's hard to see unless I'm up on a ladder. It's a sweet little mill. I got the knee down all the way, and I still had barely enough clearance to do it, but I was able to do it. Got the kick up. When I put the head on it, I built it with the some kick up offset in that block of steel, that block of steelio. So anyhow, all right. Well, that's it for the minute. I'm gonna kind of I power tapped all those using the VFD drive, and super awesome. Use the digital readout. That way, I was able to do my numbers super easy. I'm just doing it quick, getting it done fast as I can. So the next thing is to probably make up a plate that goes on there. I may or may not stuff that old nut back in there. Might buy a new one or make a new one. As you can see, like I got pieces of bronze, and I got my steel storage down there. I got pieces of little bits of everything, and this is just one of the. I got file cabinets of steel. I got a whole outside full of steel. It's a beautiful day. This is kind of my work and drill bits area. Hope the camera's not over-sunned, exposed. But I'm having fun here in the shop. Working on the tailstock ram. You can see I got it there. Everything's cleaned up and yada yada, put back on. I got you pointed at the tailstock here on the Colchester 17-inch lathe, and I showed you some machining of this. I wanted to show you the actual result. Tailstock is basically finished. Let me show you the machining I did with that nut that was the Acme nut was broken away. Let me pop this out, retracting. Oop. Got it blued up, fits reasonably nice. Okay, so what I'm going to do here is I'm going to unwind this and pop that out of there. All right, so now it's disengaged. So let me yank this guy out. Man, nice and oily. All right. So what I'm gonna do is show you guys, right? I got the bottom notched out right there. And maybe you can see inside the Acme nut. So now what this does is this is like a nut plate. It's a 2-inch diameter tailstock quill, and this is just 10 thousandths less for clearance. And I milled the notch for the keyway so I could insert this joker into the tailstock. But that nut plate, it holds the Acme thread nut in there. So as you remember, if you can see on the side there, the hole in the side, and clear it around this, you can kind of see this side maybe. Man, I don't want to drop this, this oil is a grease pig. It was cross pinned, and that's strong in one direction but not in the pull-out direction. Of course, the pull-out direction is where you eject the taper. So that's what I ended up doing. I could have put in a Dutchman, but what I ended up doing is I made like a flange plate. And those are 1032 screws, countersunk or counterbored in there. And that's what it is. So I just wanted to show you that. That was the final end result. And run that back in there. My hand's all great oily here. So that's it. And the taper's reamed pretty nice. That'll go in there pretty well. And I'll show you, I picked up a Cook brand Babbitt hammer at the flea market for 10 bucks, brand new. Man, it's surprising how heavy this is. So what I do now is I'll give it a, and that joker's in there, right? That's, you can't beat a lead hammer or a Babbitt hammer. So it's kind of nice. It's got a nice handle and everything. 10 bucks at the local flea market here, Mount Croghan, North Carolina. But like I said, this thing is ready to go now. That was the last thing holding me up. Thanks to Clapped Out Bridgeport there for letting me onto that website. I think it's Rotron that makes Acme nuts, and I still might order an Acme nut from Rotron. Half price than McMaster car, and not that McMaster is bad at all. I love McMaster. But good tip, they got any kind of Acme thread rod or nut, and they got nuts in bronze, iron, steel, nylon, UHMW, all kinds of nuts. So I'm super excited to get this tailstock running. So that's it. The only thing I had to do with this lathe is give that gap some attention because it's high by like 2 3/1000ths or something. And I might set that up on a Rockford planer now that I got my lamp. Oh, I'm ready to go there. So, all right. Appreciate you checking that out. Until next time, do the shop.